All right. Welcome to our today's tutorial. Dr. Brenner here, pharmaceutical chemistry and analysis. Okay, so our today's tutorial, we are going to look at the synthesis of pyrazole. The synthesis of pyrazole. So here is the synthesis of pyrazole. But before we do this one, I would like to tell you since pyrazole is one of the compound that falls under the heterocyclic compound containing two heteroatoms, that is nitrogen. So among those, we have this pyrazole, which has got nitrogen on position E. So here it has got nitrogen, pyro-like nitrogen. It's like this, then double bond there. So here we can put a double bond and here a double bond. So this is called a pyrazole. You get? This pyrazole, when you say nomenclature of this pyrazole, we can say on position 1 and on position 2 we have diaza. Why are we putting di? It's because we have two aza. So here diaza, then you're going to say cyclopenti 2,4 diene. Why are we saying cyclopent? Because it has got how many sides? 1, 2, 3, which is this is position 1, position 2, position 3, position 4, position 5 is cyclopent. 2,4 is because you're finding a double bond on position 2 and on position 4. How many double bonds? There are 2. That's why we've been putting di there. So that is pyrazole here. Then when we talk about the other compound is like this. You find that it will have a position on position 3 there is nitrogen, and on position 1, then on position 1 is the one that is like pyro-like nitrogen. So this one is called imidazole. Imidazole is also one of the compound that fall under the heterocyclic compound containing heteroatom, that is nitrogen. So this one, the only difference between this pyrazole and imidazole is on the position of the nitrogen. This one is 1,3. So when you're naming, you can say 1,3 because you start counting from here, which you're going to say this is position 1, position 2, position 3, position 4, position 5. You move to where you find the nitrogen near. So this one is position 1 and 3. You have diaza. Then here you're going to say cyclopenti. The double bond, you find double bond is 2 and 4. Then you're going to say diene, like this. It's the same thing, but the only position of the nitrogen, that's the difference that you find. So here we also have the other one, which is called the pyrimidine. A pyrimidine has got so here you can do like this. A pyrimidine has got a nitrogen on position 1 and on position 3. So this one is a pyrimidine, is just like a benzene like. So this one is called 1,3 diaza benzene. 1,3 diaza benzene. So it is only on position 1 and on position 3. But today we are concentrating on the pyrazole, how we can synthesize pyrazole. So these things, as you are studying, please make sure you understand their nomenclature. As you are studying, make sure you understand their nomenclature. How do you write nomenclature? Nomenclature. You understand this one. You also need to understand their basic properties, so that you are going to be able to differentiate these basic properties among these three of them. Then also you need to know the synthesis, how you can synthesize this. In short, you need to know the mechanism of these compounds. Between pyrimidine, you also have imidazole, you also have pyrazole. So our today's lesson will look at the the synthesis of pyrazole. So here I'm going to write something as synthesis of pyrazole. So I'm going to bring this guy here, synthesis of pyrazole, and the pyrazole that we are synthesizing is something like this. On position 1, there is nitrogen, like nitrogen here, and on position 2 there is nitrogen. So this is a pyrazole. So you should know that on the pyrazole, this nitrogen here on position 1, it is said to be acidic. Get? On position 1, it is said to be acidic. The reason is very simple. You may find this question in an exam or the test. Why the nitrogen on position 1 here it is acidic, or the hydrogen, let me say hydrogen there on position 1 is acidic, this hydrogen there. The reason is very simple. This is because of this nitrogen on position 1, it contributes lone pair of electrons in the aromatic character or in the aromatic sextet, and it will result being deficient or electron deficient, and which will tend to withdraw electrons from the hydrogen, and this hydrogen will become partial positive, making it to be more acidic. Get? So this nitrogen will contribute lone pair of electrons in the aromatic sextet, making it to be electron deficient. As a result, it will start withdrawing electrons from the hydrogen, making the hydrogen partial positive, and hence it will become more acidic. Then this nitrogen, which is on position 2, so this is position 1, as you know. On position 2, we say it is more basic. This is because it contributes only one electron in the aromatic character. You see, it contributes only one electron in the aromatic character. Oh, sorry. Yeah, so as we are saying, this nitrogen here is more basic because it contributes one electron in the aromatic character, which it has also the lone pair of electrons which are laying orthogonal to the ring, and this lone pair of electrons, they are variable for proton capture, as we know that the base is its use is to capture the electrons, or capture the electrons. Yeah, so here, as we're saying, it contributes on one electron in the aromatic character, and it has the lone pair of electrons laying orthogonal to the ring, which are available for proton capture, and hence we are going to say it is more basic, you get, than this nitrogen on position 1. Okay, so this is pyrazole. Let's now see to synthesize this one. So a derivative of pyrazole are formed from, we can say, 1,3 diketones. We say derivative of the derivatives of pyrazole are formed from the 1,3 diketones and the hydrazine. You can say hydrazine. You know how hydrazine is, I believe so, and or substituent of hydrazine. So we can have hydrazine and or substituent of hydrazine. So what do we mean by saying that? When you say 1,3 diketone, it means that you are going to do this is okay. All right, so we can say something like that. 1, 2, 3. This is 1,3 diketone, or we can say or 2,4 diketone, but this is 1,3 diketone. So this one will be the first position, 1, 2, 3 diketone, like that. Then reacting. So this one is an exam question, reacting with the hydrazine. So which is 2, then 2 like this one, then you have water, then the product that you're going to have is the product is what? The product is pyrazole. So here you're going to have this. So this one may come as a predicting the major product. You need to know. So this one Okay, something like this. We need to know. So here, this is a pyrazole. A pyrazole, should you know that a pyrazole has got a nitrogen on position 1 and on position 2. These are things that we need to have. So when you say 1,3 diketones and the hydrazine or the derivative of or the subsequent hydrazine will form so here is what you form, what we call a derivative of pyrazole. You get? So the first thing that we're supposed to know, this is a derivative because you have these substances that are connected to that. But what we have looked at, this is a pyrazole. Then this one has got the substance, which is called a derivative. Let's try to write the mechanism. You may find the exactly mechanism in an exam, but it will be very easy for us to do it. So I'm going to write mechanism. So here you're going to have this. You're going to have this, the same one that you have been given, like this. Then here, like this, like that. Okay. So I'm going to bring that hydrogen, which is this, with how many hydrogen? 2 hydrogen. Here they're saying there are 2 nitrogen. They're also it's supposed to be 4 here, sorry. It's supposed to be 4. We can put, so here it's supposed to be 4 hydrogen. So 2 nitrogen and 4 hydrogen. So it means that here you have 2 nitrogen and 4 hydrogen, like this. You get? Yeah. So what you're going to do, these has got lone pair of electrons. So here, lone pair of electrons. So what you're going to do, these will come and attack this. You see, you can even use any. If you want, you can start with this, attacking this. So most you need to do like this, attacking this hydrogen, this carbon there, then this one opens like that. Then what you're going to have this. Okay, so you're going to have this. I can put this to say, okay, this one, something like that. Then here, okay, so let me write something. Okay, where you have attacked there is this, which is the CH3, right? You can see the CH3 there. Then there, which has opened there, is this one, like this. Hope we are okay. Then this one, because you are where it has opened, is like this. Okay, let me just put it nicely. So okay, so here you do like this. Where it has opened here, you said it has opened, that's this one here with a negative like that, you get? Then here there's CH3, which is this one here. Then what will happen, you have connected this nitrogen with how many hydrogen? 2. Then also here like this. Okay, then here you're going to have this, something like that. It's the same thing. So here, as we know that the hydrogen will have a positive charge. So what will happen to that? This is unstable. It needs to have a partner for it to be stable. So we're going to have this this oxygen to come and attack this hydrogen, or to come and get this hydrogen. Then this bond will break and all the electrons will go toward what? Toward the, so here there's like something like that. Okay, after this has reacted, this one has opened, then you're going to form this. So here, when you reach this one, this nitrogen will be taken by this oxygen. Then what will happen to this? All the electron will go to that. So here you're still going like this. So I can even write like this. Okay, can even write like this, the way it is. All right, so here now we have OH, CH3, then here nitrogen with 1 hydrogen, then nitrogen with how many hydrogen? 2 hydrogen, like that, you get? So after reaching at that point, what are we going to do? It's very easy for us to say this one also has got a lone pair of electrons, which we are going to say this one can come and attack on this hydrogen there, on this carbon there, then this one will open, you get? This one will come and attack on this carbon there, or carbon containing, which has got a carbonyl group, then this one will open. then what you're going to have something like this. Okay, you're going to have something like that, this. Then here, as we know that there is CH3, then there is also OH here. Then here there is a nitrogen with one hydrogen. Then here we have a nitrogen with how many hydrogen? 2 hydrogen there. Then it has made a bond with this carbon there. You've seen that this one, this position, this is the position here, that this is the position there. You get this one here. So here, or coming to this, where you have made a bond there, and the other one which has got which has opened, this is the one that has opened. Then we also have this here, which is methyl. So I'm going to write here methyl like that. You get? So at this point, what are we going to do? So it will be very easy for us. We are going to also to use intermolecular reaction, which we are going to say this one is unstable, or come and get this hydrogen, because here there is a positive. Why? This nitrogen is connected to how many bonds? It's supposed to connect to 3 bonds, but it's connected to 4 bonds. That's why it has got a positive. So this bond will break and all the electrons will go toward what? Toward the nitrogen. You get? So you show it nicely. Okay, show it nice like this. Even the arrow itself, like this. Okay. So you're going to have this. So here there's OH now. There's the OH. Then here there's CH3. Then N there with 1 hydrogen. Then it is stable. Then here we said D has OH also, CH3 like that. Okay, that's why we are there. You get? This is hydrogen. Oh, sorry, here there is something like this, nitrogen with hydrogen like that. Okay, so here you're moving. Okay, this one has OH on this position. Look at it. Here there is OH, then CH3. Also, if on top there's OH and CH3, but we want to remove this OH there and come up with a product. So what are we going to do? We are going to use a base. So here there is a base there that we are using. How? Okay, good, very simple. So here the base from water, which we are having there, that's the one that we are going to bring at this moment. I'm going to use the same one. So you can use this hydrogen there, which is like this. You bring this base, you get, and you come and get this hydrogen there. Then this bond will break and make a double bond there. What will happen to this? Will go this OH there. Then here you're going to have this CH3. Then this one we're going to have, oh, this one has gone, right? And we'll have a double bond there. And this one has like this. This one is CH3 with OH there. Get? Something like that. So also the product that we're having, remember I'm showing the arrows. So we want to remove also this OH. This guy which has gone as OH is the one which will come and react again. This is the one that will come and react again. I'm going to isolate 1 hydrogen, as we know that there are 2 hydrogen there. So I'm going to bring this and come and get this hydrogen there. This bond will break and all the electrons will make a double bond there. You get? When it makes a double bond, this OH will go. So what you are going to have, you're going to remain with this, something like this. Here there is CH3. Even here there is CH3. Okay, so looking at the product that we're having here, they're saying this, we need to use this 1,3 diketones with this hydrogen to come up with this product. That's what we have. So here you use this lone pair of electrons from the nitrogen, reacting here on the carbon that has a carbonyl, and this one will open like that. Then will form this product, since that it has made a bond here, and here it will be unstable, it has got positive, so there will be intramolecular reaction where this negative here from oxygen will come and get this hydrogen, then to be stable, that one will be OH like this there. Then here the other nitrogen here has got a lone pair of electrons which will come and react on the other carbon that has got a carbonyl, and this one will open, will do the same. Here it will be unstable to have 4 bonds, then there will be intramolecular reaction getting this hydrogen there. Then when you reach at this point, we're supposed just to make a double bond by using a base, which is this one will come and get this hydroxy, will come and get this hydrogen. You can even start from here, it's just okay. And this one will make a double bond, this OH will go. This OH will be the one coming and getting this hydrogen, making a double bond there, and this one will go. This is how you go about the reaction or the synthesis of pyrazole. Then you come up with the reaction, which is this, or you come up with a compound that is this as our product. That is pyrazole, position 1 and 2. You get? So here, if you want to name this one, just for the quick we can name it by saying, okay, what we've learned is there are 2 methyl group, right? So this methyl group we have on position 3 and on position 5, which is position 3 and on position 5 dimethyl. They are dimethyl because they are 2 methyl group. Then here, now the parent name is 1, 2 diaza cyclopenti 2,4 diene. So this is the name of the compound that we are synthesizing. Alright guys, thank you so much for watching this video. Please subscribe if you haven't subscribed, as we are helping one another.